So when you got there, what was the level of development of the pumps, and what did you see at your time there?
Their beginning first stages was a stainless steel hand pump that was actually mounted to a ABS well seal, a plastic well seal.
So the pump head was mounted to the well seal?
It was mounted to the well seal, and that was mounted to the casing itself. But that wasn't stability enough, and it used to rock back and forth as they would pump the hand pump. At that same point in time, they were using a PVC cylinder that was a different design cylinder, but being PVC pipe, the bore consistency of PVC pipe was inconsistent.
Right.
And they couldn't get it to seal correctly. They were using an O-ring design, but it wasn't consistent enough, and it would get bypassed going through it and everything else.
So you moved from the well seal to something more like you have now? How'd that work?
Originally went from that to mild steel, and from that mild steel, they would sandwich a steel plate on the top, and they used a same ABS well seal, so it would be seal-proofed to the well itself.
Right, so the well had
they
seal.
had bottom plate, and then from there they would marry the stainless steel plate of the pump on top of that, and they did that for a while, and where they were still getting the rocking issue.
Did you have any issues with having mild steel and stainless steel and
mild
anything
steel
there?
We were finding that's cross-contamination with the stainless steel. You don't want to use any tooling or having the dust in the shop.
Probably like when you're polishing,
Polishing, yeah. Grinding.
You're right.
We were grinding the seal, the top plates, the well seal components. We were grinding all that, and all that dust was landing on the stainless steel, and that could have rust contamination to it.
Right.
So we had to do something there. So we went to totally stainless steel.
So did you still have the well seal then?
The well seal was still in. It was all done. We used the same rubber well seal as every well has on every well.
Right.
And we incorporated a stainless steel bottom plate and a stainless steel ring and top plate. And then we married another stainless steel plate on top of that. So finally we got rid of the top plate and made the pump welded directly to the top plate of the well adapter itself.
And you were able to do that when you got some more advanced equipment?
No, at first we were cutting everything out by hand and grinding it up. But
well, that was good for you, because one thing I've learned going through this with Lee is he's very artistic. And you make a lot of these ornamental things, so
yeah,
I was really surprised to learn that about
Thank you. So then it was from that point on, we because the steel with the mild steel one was, we were not only grinding it, we were painting it too. So there was painstaking time involved painting all the plates, and then hanging them up to dry and everything. So if we did it all out of stainless steel, everything was moved production along a lot quicker.
Right. And so that's the basic design that the pump head is now, right? The well adapter.
It's the same thing. The only other improvement we did from the well adapter itself is the original bottom plate was, we used to weld the bolts in place, and now we punch square holes in there, put carriage bolts on it, put our keepers in there, and in case a bolt gets broken, the customer doesn't have to send the entire pump plate back to us. They can send, we can send them a carriage bolt and a keeper, and they can replace it themselves.
Right. So we moved from there. Now, when you got there, and you're doing that part of development, but there really weren't any drawings either, right?
There was no drawings. We had some sketch measurements in a little tiny book for like the rod and the pipe and stuff, and I had to develop some of the drawings. I had a little bit of a CAD program, so I started making drawings of all the pumps, all the measurements, something to work with.
Right. And where did you get the background to do the
It
drawings?
was just a night course that I took in for CAD, and just kind of trial and error.
Wow.
That's basically what it was.
Yeah. Well, so what about there's a filter on there now that wasn't on there before, early
Correct.
on.
The vent filter?
The vent plug, yes.
Yeah, the vent filter, we used to just put a plug in it, and people's wells eventually were causing a vacuum in their pump, and it was getting irregular pumping action. So we always said we needed a vent, and we tried looking online, trying to find a vent anywhere, couldn't find anything, and every vent you came across was a mesh filter, but it left contaminants to come inside in the well casing, like any places that flooded over.
Right.
You'd get contaminant water in the well casing. We didn't want that.
Right.
Even if you put a return like a 90 style on some pumps, they got like a 90 style on some vent well adapters. They got 90 style.
Right, where it just kind of does a little horseshoe. Right.
But you can still get water and contamination inside that. So I went hunting for filters. I went hunting for looking for different designs. Couldn't find anything. I finally found a stainless steel mesh filter, and at this one company found it. What it would do, you could actually get a droplet of water to sit on top of it, and it wouldn't penetrate down through the filter, but it would filter air. So just by a little vacuum air, it would filter it to go through there. But then we needed something to actually make it sit there inside. So I just thought, make it something to make it rounded looking. Didn't want, something godly looking on top of there. So I made like a round, like a mushroom vent.
Right.
Mushroom design.
It's kind of a mushroom head now, isn't it?
Kind of mushroom design, and then the filter stuck in the bottom of it.
Right.
I had some orifices that went up on an angle, and the small orifices that wouldn't allow water to get in there also.
Right.
Did allow it to vent out.
And that's like what, a 10 micron filter?
I believe it is.
Yeah, that's one. So that's kind of the end development where we are right now, right?
That vent is still continuing today.
So the other big thing that I've seen with the older pumps to now is in the packing gland area. Why don't you talk about that?
Originally with the packing gland, every style packing gland out there that has a reciprocating shaft that goes up and down, it's just a packing rope. That's all it is.
So that's like our lift rod is the reciprocating rod.
Right, exactly. So if you get an impeller on a ship or something, that's all done with a packing rope inside that. So that's what they were thinking at that same time. They used a compression fitting.
Is that kind of used on some kind of tanks or something you were talking about?
Because it was a plumbing company that developed the pump,
right?
They decided to use a tank fitting. A tank fitting was a half-inch compression fitting, and it allowed to pass a half-inch copper tubing through it. If you went and got a regular compression fitting, half-inch compression fitting, the body of itself would only be 3/8 diameter. This here was a half-inch diameter. So there was no drilling involved. There was no more machining involved to get our rod to pass through that. So that's why we use that design. And then at the top, we'd use 1/8" Teflon packing rope. It was pretty easy at the time. We'd get a little package of it, a 30-inch long package. We only cut 7 inches off it, so you can use that quite often.
Right. So what caused you to move from that to where you are now?
The packing gland, the cup seal, the little fitting, the brass fitting, the top cap would keep wearing out, and eventually we would just we got to find something different to use, and we were thinking about going from the O-rings in the piston to cup seals, because every hydraulic cylinder that I've always been used with was all cup seals.
Right.
They gave the most power. There wasn't any bleed by or anything like that. So I thought, why can't we use a cup seal in that packing gland area? So we developed a design for that. The original packing gland was a brass cap. We used to thread the top of the pump, and we had that brass cap on there. And then we had to use the compression fitting had to be silver soldered into the brass cap. So when that wore out, it was more process to do it and everything. Where the cup seal, we could make a gland nut, one gland nut. Now it's just a cup seal, and you're done.
And so, why are you sealing around the lift rod in the first place?
Because as you pump the hand pump, the water will back up a little bit and weep water out of that. If you were pressurizing your pressure tank, and you cause you're pumping through a pressure gauge, a pressure check valve, you cause a lot of back pressure on the spout as the water's flowing out the spout. It's got to go somewhere, so it goes out least resistance. It would go out through the packing gland.
Yeah.
So with a cup seal on there, now that holds all that pressure down, and it's easy to replace, and you don't need that much pressure on that. With a packing gland, to keep all that pressure in there, you need more of a tightness area there to compress that packing rope in there, and the cup seal takes all that away.
Let the cup seal do all the work, pretty much.
Seal does all the work, yeah.
So there's an adjustment that we ask the customers to do with the gland nut and the cup seal. Talk about that for a minute.
As you're pumping the hand pump, that packing gland nut only has to be threaded on there real loosely. A couple of threads, and that's all you need. And as you pump the hand pump, if you get a little drip of water out of there, no big deal. You know, go back to the old cast iron hand pumps. That was all wide open, and water would come up and bubble out of that, or acid rain would run in, or bird droppings would come in there. You don't want that now. So
that's really also part of what it's doing, is protecting the well integrity, right?
Yes. Yeah.
So the gland nut's actually is compressing the cup seal over time. Like whenever you pressurize, you clamp it down.
You have to clamp it down. As you pump the hand pump itself, you would just adjust it quarter turn at a time until the water subsides from seeping past the rod, the rod itself. And sometimes the more you clamp on it, if you clamp on it too tight, you're going to put more stress on the rod as it's trying to go up and down. So you could be wearing that packing gland out quicker. So it doesn't need a whole lot of pressure there.
Right. For it to do its job, it really doesn't have to be threaded down all the way, which is
correct.
Which is a lot of what we run into.
Correct.
The other big thing that has had a lot of development is how the lift rod's connected to the handle.
Oh, yeah, yeah.
And we call that an eyelet.
Yeah, the first pump rod itself, we used to take a stainless steel nut, bore it out, and weld it to the top of the rod, the lift rod itself. We used to weld it to it. And then we used to put a shoulder bolt through it. Well, those 2 points would wear out quick.
Because you had metal on metal, right?
Metal on metal. So
right.
We tried to get something different. So my background, I thought, why not a bushing in there? We were thinking of ball bearing, but I couldn't get a ball bearing that small at the time. So I figured, well, just use a bronze bushing in there. But the bronze bushing it was small enough that it wouldn't go into the nut. So we figured we'd get rid of the nut. So we made an eyelet, kind of rounded top, kind of like a tombstone design to it, and put a bronze bushing in it. And then to attach it to the rod, we first started out with a 3/8 thread on it. But the 3/8 thread over time was stripping out and breaking.
Okay.
So then we went to a 1/2 inch fine thread. So there was no more now machining the 1/2 inch rod down to 3/8.
Because the lift rod's 1/2 inch.
Correct.
Right.
Right. So then we just went from that, and that stayed as a 1/2 inch fine thread on that. Then we put a little Allen screw on the back side of that to hold the rod. And the rod, because as you're pumping the hand pump, the piston wants to spin and wants to spin everything inside there. So if you trying to spin the rod out of there, it would eventually spin the rod right out of the eyelet.
Right.
So we needed a set screw to hold it in place. First set screw was just a nylon tip one, because we didn't want to damage the threads on it in
Right.
case we had to take the packing gland out of there.
Right.
So we ended up with that.
So you went to the roll pins then, right?
We went to the roll pins afterwards. Yeah.
And those were not that bad from a manufacturing standpoint, but from a customer's view, they had some difficulty, right?
Correct. Yeah, because it would have been nice. It was nice to keep the Allen screw. I mean, the set screw in there, just a little Allen screw. You could wind that out of there and then spin the rod out of there. Well, with the roll pin, you can't. You have to get a smaller size punch. You have to have somebody hold pressure on the back side of that rod, that eyelet,
To
as
remove
you're
it.
driving that pin out of there, and that created a lot more headaches for the customer's standpoint.
Right. So when they're in the field trying to take that out, it's a little bit more of a chore,
It's
right?
more of a chore. They need the exact same punch size as what the eyelet is, a little smaller. Then they need a couple of hammers. One is a backing hammer, and the other one to drive the pin through.
Right. That was one of the frustrating things for me whenever I was first encountering this.
Correct.
And so now,
So now
Yeah.
it's designed just right. It's got an Allen screw on it, but it's got a pin in it. And the pin, once you undo the Allen screw, the pin slides out, and that pin actually goes right through the body of the eyelet connector and the rod itself. Super tight connection, just perfect.
so it's kind of the best of both worlds. Kind of a roll pin with the set screw combined.
Correct.
Is kind of what it ends up being, and,
Correct.
and that's where we are now. So it's a lot easier for the customers to take that out in the field, and that's what we're trying to accomplish with that
Correct.
improvement, right?
Right.
The handle hasn't always looked like it does now.
No, it was originally the first handle. They didn't have a bender. Prior to me getting there, they didn't have a bender to doing this. So they would cut square stock and make it trying to get it as round as possible, but we're using square stock and welding it up that way. Then eventually they built a shop press, a shop built press to bend the 90 on the handle.
And because you're trying to get a certain look, right?
We were trying to get the pump to look like the old cast iron hand pumps,
Right.
but with the stainless steel, the new version of stainless steel to it, and still have the top encased, so it would be in vermin proof or whatever you want to
Right.
call it, and
And be able to pressurize.
to be able to pressurize, and that's the biggest thing that was with Bison pumps is we could actually pump up a pressure tank when the power was out.
Right. And that kind of rolls you all the way back to the beginning of you need water when there's no electricity.
Correct.
You can actually use a pressurizing kit to pump into your pressure tank.
Correct.
And then your entire house then is filled with water for however much water you have in your pressure tank, right? Until you drain that out and then repeat. But that makes it really handy inside the house.
It does. It does.
Then you're not having to carry buckets in. You can actually go to your sink and use it.
Correct.
And
Yeah.
maybe flush. That would be awesome too.
Exactly. Yeah. I mean, you can take a a bucket and flush a toilet with, but it's convenient if you could pump up the pressure tank, get a few extra gallons in it. Because I mean, when your electricity is out right off, you've got water stored in your pressure tank, so you're not totally out of water. You can run a little bit of water. You can flush your toilet for a little bit. You can't. Probably wouldn't be in to take a shower because it's going to be cold water because
right.
the electric heater's up, So, but you still can be able to get water.
Right.
So now where you get the capacity to pump water in your pressure tank, and then you can keep on going that way, So it makes it more convenient.
So one of the other areas that I've seen that there's been a lot of changes is in the cylinder area. So talk about the cylinder.
The cylinder, originally the first cylinder we started with was a PVC cylinder. PVC end caps, PVC. But PVC, again, was not consistent bore inside. So we were trying to get something that was as smooth, and we couldn't find any PVC that had a consistent bore to it. And the original ones, the O-rings that we were using, as you pump water at deeper depths, the water would just bypass that static seal. And we wanted something that would give you like a reciprocating motion, just like a hydraulic cylinder.
Right back to what we were talking about on the lift ride.
Correct.
Same thing.
Same
right?
basic design, yep. And that's where we tried to get better at it,
So the first cylinders were PVC bodies, and now they're all stainless steel bodies.
They're all stainless steel, yeah.
And the pistons themselves were PVC, right?
The pistons themselves were PVC. The grooves for the piston, for the O-rings were PVC. We used to make all this. We used to make all the check valves that went in there, and the first check valves were made from PVC products that pertain to the plumbing industry. Fittings, just go to a shelf, pick out this fitting, that fitting, this fitting, and go to the lathe and start making a check valve. And that's how we started.
And so the check valves for is really what moves the water, right?
The piston is what actually moves the water, but you're going to have a check valve down at the base to actually, when the piston goes up, the water comes into the base of the cylinder and the check valve will close. Now that water stays there. As the piston goes downward, the water goes from the bottom of the piston up to the top of the piston, so you can be delivering to the pump head.
Right. And so the check valves that you started with is not the ones that we have now. So there was some development of that, right?
There was quite a development in between time. I was in 05, after making those shop-made ones, which was time-consuming, I was looking for something that was more off-the-shelf bought, and couldn't find anything, and finally found a company that would supply me with a check valve, but it was brass, and it was really expensive. So I took that same brass check valve, drew it out into a CAD program, and made it really smaller to fit our pistons, because we had 3-inch, 2-inch, and 1.5-inch cylinders.
So you needed them different diameters for each one.
Different diameters. And they still wanted to stay with the threading design because that was what plumbing fittings was.
Right.
So we stayed with the plumbing fitting design, threaded, but we had to get rid of the hex on the design of the check valve. So we went to a spanner style. So you had to use a spanner wrench, like a two-point, two-hole style. And it was okay for us because we had the tools to do it with. But to get a customer to do this, we'd either have to send them a tool, or sometimes the tabs would break out.
So we're back to having a component in the pump that's okay for us manufacturing.
Correct.
But for the customer to do maintenance was a problem.
Correct.
And so we wanted to address that with.
thinking of way of ball valves and springs and stuff and stainless steel balls and stuff, but it wasn't giving us a positive enough shut off from the flow itself. And the O-ring design that in our check valves was giving that, you know, with the spring design, that was giving us a better control of the water staying in the hand pump itself.
So you eventually found a company that made a check valve.
They were a plastic company, and they would actually make custom design ones, but they needed a drawing. So I sent them the drawing. They started making it for us, and everything was going good. But as eventually everything goes up, prices were going up. So, excuse me. Then I had to go look for another style check valve. I wanted to get something that was a cartridge style,
as opposed to the threaded.
As opposed to threading. Threading was okay. It was quick and easy for us, but it was bad for the customer.
Right. So what did you find?
I found another actually, I didn't. At first, I didn't find anything. I found a electric pump that we had on the shelf that used this type of check valve, a cartridge check valve, but it was embossed in a stainless steel body in their pump design. So I called that company up and asked them what type of check valves they were using, and they wouldn't. It was prioritized to them. They wouldn't tell me.
So you had to do some research to find who the company was yourself.
Yeah, so I took that check valve design, cut the body open, found the check valve that was in it under a magnifying glass, found the name of the company that made the check valve, went online and looking for it. Then I had to find after contacting the company, asking them if we could be an OEM company to sell to us.
And so they did, and that's the check valve we're using now, right?
That is the check valve that we're using today, which is a nice, easy check valve.
And it uses a snap ring to stay in
place.
Right?
Yeah.
So one thing that customers ask a lot is, does it hold its prime? And one thing I've seen with your design difference is the foot valve has moved locations.
We originally, our cylinders had foot valves, regular off-the-shelf style brass foot valves, which was easy replaced, but the cone shape on the bottom, the screw would rust out, and then the cone would fall off it. So when we went to the new style check valves, we mounted those in the end cap and put on a plastic screen at the bottom. So that plastic screen can be taken off, and they can put drop pipe on the bottom of it. They can put a silk screen on the bottom of it. You can do a lot of different other applications.
It just gave us a lot of flexibility when we were able to do that.
Yep.
So you've spent the last 15 years working with Bison Pumps, developing it, improving it. Now you got the premier product in the industry. Pretty proud of you. Good job.
Yep.
Tell us what you're doing with Bison now.
I'm a technical advisor for Bison Pumps. People call basically the same thing. They've got an issue of how to install it, how to find out what they need, and if there's certain apparatus that's down in the well, we need to get that changed over, or they need to drill a new well just dedicated to a hand pump. Or when in my time don't stop then, it continues if they've got an issue with water, if they've got an issue with quality of their water, if they have an issue that the pump is not pumping correctly, or they're not happy with it, so I try to diagnose their issues, help them right on over the phone.
So you're doing all of the technical assistance, and you're still working with Bison and consulting with us as well.
I'm consulting with the company also.
Right. So
on new development of what they're doing, because they don't want to just jump in and change something. It could change something down the road.
Right. That's a lot of what we've learned is you've already traveled a lot of roads. No sense traveling them again.
Correct.
So we're trying to not reinvent the wheel as we're going along and learn from what you've been doing all these years. So that's giving you a little more freedom because now you're not stuck in the office and you're able to do technical support from this beautiful location right
Correct.
here. And
I'm up here in northern Maine. It's like you said, beautiful location, and I could be here with the company phone, and I can be in corresponding with the shop on the shop floor, the sales department, and the customer all at the same time. Need to be.
And the whole time you're here, then your wife has to work. It's just, she's in the office. You're stuck out here looking at Canada. You know, it's a rough deal,
Yep.
isn't it? So with all these improvements, then over time, everything that you've been working on, that you've been telling us about, is improving every product as you went over the years from 2005 to now is, 15, 16 years that you've been working at that.
Yes.
And the end result was Bison is the premier hand pump in the industry.
Correct. Yeah.
Tell us why Bison is a premier hand pump.
Bison is the premier because, for one thing, it's made out of all stainless steel. The other thing, it was craftsmen that actually designed this pump to make it work in so many applications. We had shallow well pumps and we had deep well pumps. And all those pumps, that design could be incorporated to help every application for people to get access to the water. And that's what was making the Bison. The only other thing after that with making Bison was our customer service. We could explain to customers every aspect of their well. They would describe us in a very short, say if it was a 6-inch well, fine. What's in that well? Is there a pitless adapter? Is there a block-off plate in there? Is that well artesian? Is that, technical service? We go well beyond our scope prior to it because we want the customer's package to be correct and everything to work correctly on it.
Do you ever have customers call you and know very little about their well and you have to work with them any?
I work with all types of customers over the years, and a lot of them, sometimes they'll tell me what their problem is. I'll ask them if they're mechanically inclined at all, that I could walk them through a repair on site. And I have walked people, husband and wife team, over a weekend, talking back and forth to them at different points of time, and they got their pump working again correctly without having to send it back to the shop.
So what about when they're in the buying process? Is there any information that you have to work through people with?
A lot of different applications every well is different. And I talk to people all across the whole world. Doesn't matter. Sometimes a language barrier is a little different, but if you work for it, you can get it, and ask them to do a little drawing, tell us our static water level, tell us what's inside the well. If you don't know anything like that, you can go to maybe you have a well report, maybe the county commissioner has a well report, maybe the town hall has a well report on your well. Get that, send that in. Take some pictures.
Maybe they have a dug well.
If they have a dug well, we got flat flange pumps that can go on dug wells, on covers. We've got shallow well pumps that will work with that.
I know I've worked some with you where they actually have like a pit where the well's actually below ground and they're wanting the pump head above ground.
Correct. You take a pit like that, it's usually 4 or 5 feet down, and that's where their well house is, or well pump is down in there, and their submersible pump is down in there. I mean, not submersible, their jet pump is in there. So how you connect something like that to get a hand pump on it? We would do a special adapter on their casing that would incorporate the Bison hand pump, the well seal, bring the pipe right up to the top, put a flange on the top on ground level, put a hand pump on that, and they still have their submersible, their jet pump down in in the pit.
So with our technical support, customers with non-standard setups, I guess you could call it, you can work them through how to incorporate the Bison pumps into their well?
Correct, yeah. Every well is different. 6-inch, 5-inch, 10-inch wells. Some of them got a 10-inch well, like a lot of them in California got 10-inch wells or 8-inch wells, and they have a 4-inch well, actually well. And it could be offset, so a picture is worth 1,000 words. Take a picture of it. Give us a little drawing. Set me what it is, and from there we can work you up a pump that will fit in that same setup.
So you even, when they get smaller, like a 4-inch and they have an electric submersible, you can even help them with that, can't you?
We developed what we call our inline pump, and our inline design is, if you've got a 4-inch casing and you're like in California where like in the southern sections, because it was originally developed for people like in Florida or Georgia, areas like that would submersible pump that was already in there. We needed submersible pump water to pump directly through the Bison setup. So in order to do that, we needed to hold the end caps together and hold all the weight that was above the pump head and below, above the cylinder and below the cylinder, plus with the submersible pump on there. So one of my colleagues, the employees that came in with me in 05, he developed a tie rod design system. And we looked at the tie rods because me being familiar with hydraulic tie rod cylinders that holds the end caps together, and that's what we designed to use.
And so now customers, so that ties the two systems together, right? So the submersible is tied to the Bison pump.
Yeah, actually systems. The pump will pump water directly through the Bison up to the top of the well cap, and then there's a provision, another T on above the well cap that'll pump water directly to their pressure tank.
Yeah.
Because their pressure tanks are outside, and there's a ball valve at the end of the spout that shuts that pressure off. That's why you needed more of a positive seal at the packing gland to control that pressure also.
Gotcha. One of the things I just remember when we're talking about the cylinders, we didn't talk about the different diameters and why there's a different diameter and what that does for the customers.
If you have like static water levels of 0 to 80 feet or so, and you got a 6-inch casing, you can use like a 3-inch cylinder. You get more volume water out of it, less effort. The deeper you go, the more effort it's going to take to bring water to the surface. And after eventually we started going, well, okay, we got the 3-inch cylinder, we got the 2-inch cylinder, and an 1.5-inch cylinder. Well, the 1.5-inch cylinder is small design, but it will bring water to the surface. But the deeper you go, that pump was originally designed to go 300 feet. But after 300 feet, it would be a lot of rod, a lot of pumping, and very little water.
So my guess is at 300 feet, you're lifting a lot of weight.
You're lifting a lot of weight. You got the column of water. A lot of customers will try to get their pump down as deep as possible, and it shouldn't be down. Even though the static water level might be, say, 120 feet, they'll go, well, I got better water down 400 feet, and I want it down 400 feet. No, it's not possible to put that down 400 feet because you got head of pressure on that, and you got stainless steel rod on that, and all that additional weight is all reflects back on your effort to pump the handle.
Right. So then as their static water level gets deeper, then the cylinder gets smaller to accommodate,
Small.
right?
Correct. Yeah, you just, it's like we originally developed a T-handle pump. Actually, we were developing a T-handle pump. And after a while, T-handle pump, you just couldn't pull that hand. You get so deep and that handle just, you get so, it's too much to pick up.
Right.
I mean, you take a small cylinder, like an 1.5-inch cylinder, just trying to pick that up first, that's 8 pounds in like 50 feet, It's just so much weight.
Right.
So it's too much weight to do anything like that. So we went, we made a handle, made it so you got a fulcrum point.
Let leverage do a little bit of the work.
Let the leverage do the work.
Yeah. Because a lot of customers don't realize you're lifting hundreds of pounds at some of these depths.
At depths, correct.
And so that's quite a bit. And of course we adjust the sizes of the cylinders to keep that difficulty or the pressure on the handle at a reasonable level as you're getting deeper, right?
Correct.
And of course your water output changes accordingly, but at least you're able to do it. Picking up hundreds of pounds, that's a chore in itself. So looking forward, you looking forward to continuing the technical support?
I'm getting up in age. I have retired. I am getting up in age, and I thought, well, a nice job would be to go to like the shows and do meet the people on the show that the water shows and things like that. Mother Earth News or
right. And there's a lot of like water departments, like the Minnesota water departments. All those kinds of deals. They have lots of them around the country. Now, it'd be kind of hard to do that without taking your wife with you.
She's going to be hopefully retiring pretty soon.
Yeah.
And it'd be nice.
Well, then that would free you up even more. I mean, it's hard to leave this place, but that sounds like quite a good endeavor, yes. And and because it's been my experience, there's nothing like actually meeting the customers and hearing them face to face.
I get so many customers talking to them on the phone. They are so appreciated of me talking to them. Because I'll answer the phone, 8 in the morning to 8 at night, 7 days a week. When
nothing like retirement.
Yeah, so it's just but it helps them out because sometimes they're working and they can't do anything or figure out what they need for their well until the weekend.
Right.
So when they call, I'm here to answer their calls.
Well, we hope if everything continues to open up that maybe we can accommodate that. Of course, it'll take someone else that we know of that has to, you need your traveling partner with you. That's one of the things that I found whenever we go, because we just were talking earlier about Bison's a premier pump. When people walk up to that cart that you designed, by the way, which is awesome, the pump cart, and they see the pumps on there and they touch them and they rub them like they're petting a cat or something, and they're just amazed at the actual quality of the pumps, and that's a really good feeling to get to see that with the actual customers.
Yeah, because originally when they went, you'd go to the shows. He'd have the former owner would have to package up all the material and everything, and carry like 2 and 3 cots, try to get that to the show, and then open it all up and let somebody pump it. But and they would only have like a little pail of water underneath, and kids would come up and they'd be wailing on the pump and they'd be gone by that time. So I figured make like a kiosk, cot design. Put all that stuff inside it, open that all up. Now everything is displayed. You get this display rack on the back and everything. Your pump's there, and it's on the recycling water. There's a reservoir inside the cot, and you can see it it's all plastic well casing on the outside,
Right.
acrylic casing, so you could actually see how a submersible pump gets inside there.
You can see the pitless adapter in
See
there.
the pitless adapter, you can see everything in there. So
Right.
that made it convenient. And we had our shallow well pump, our model 1900 pump, mounted on that same cot, use that same water. So you pump that, and you can see how the water gets recycled.
Now, the one negative to it is when you get a 5-year-old boy on the end of that pump, there's water everywhere.
Yeah, we had to do a screen in the sink, and we just took a regular screen like these here, made a little framework, so the water as it went in, it didn't splash back up.
Yeah. And I could see why. Well, I hope that happens, that you get to do that. And I want to thank you for coming today and joining us. Thank all of you for being here. And for those of you who don't know, I won't say the year, but happy birthday, Lee.
Thank you.
It was his birthday. This is his birthday week. He's not used to those. But so we appreciate his time and your work with Bison Pumps. And thank you very much for your time.
Thank you.